Hello everyone, myself Soumya BG, Assistant Professor, Department of ECE, SJBIT. In this session, I will be discussing about the Module 2 topic of microwave and antennas. The topic of discussion is waveguide Ts. The waveguide Ts are 3-port components. They are used to connect a branch or section of the waveguide either in series or in parallel with the main waveguide transmission line. And the purpose of this waveguide Ts is mainly to provide splitting as well as combining power in the waveguide system. The waveguide Ts are 3-port components and they are mainly used to connect a branch or section of the waveguide either in series or in parallel with the main waveguide transmission line, and they are mainly used to provide either splitting of power or combining of power in a waveguide system. Coming to the two basic types of waveguide, E-plane waveguide and H-plane waveguide are the two basic types of waveguides. E-plane waveguide is called as series waveguide. H-plane waveguide is called as shunt waveguide. These are named, the E-plane and H-plane waveguides are named according to the axis of the side arm, which is parallel to the E field or the H field in the collinear arms. The names E-plane T or the H-plane T comes depending on whether the axis of the side arm is parallel to the E field or the H field in the collinear arms. Now, because of the junction, the waveguide Ts are poorly matched devices. This is a main disadvantage of this waveguide T. And adjustable matching reactance can be introduced by means of a tuning screw at the center. So, in order to overcome the drawback in a lighter manner at least, a adjustable matching reactance is being introduced. It is introduced by means of tuning screw at the center. Now, because of symmetry and absence of non-linear elements in the junction, the S matrix is symmetric. This is very important property of the waveguide T, because it is having a property called symmetry property, and in the junction there is an absence of non-linear elements. So, the S matrix is symmetric. It means we can tell that Sij is equal to Sji. I value may be 1 and 2 and J value may be 1 and 2 if I consider this 3 cross 3 matrix for this waveguide T junction, the E-plane T junction or the H-plane T junction. Since they have got 3 ports, 1 and 2 are the collinear ports and 3 will be either E port or the H port. So, accordingly, the S matrix consists of 3 cross 3 elements. It is represented as S11, S12, S13, S21, S22, S23, S31, S32, S33. But since in this case, as we already discussed about the symmetry, Sij is equal to Sji. Therefore, we can substitute S21 by S12 and similarly we can substitute S31 by S13. Okay, like this we can apply the symmetry property for all the waveguide Ts. Now, this is the representation of the E-plane waveguide T and H-plane waveguide T. Okay, in this E-plane waveguide T, which we call it as series T, as you can notice here, the port 1 and port 2 are collinear arms, and the one which is present vertically, which is having the axis parallel to the E field direction, we call it as a side arm or port 3. This can also be called as E arm, and the representation can be written in this way 1, 2 and 3. And you can notice the direction of the electric field also here. And coming to the H arm, waveguide junction or H-plane T, or we can also call it as shunt T. As you can notice here, the port 1 and port 2 are the collinear arms and port 3 is the side arm. And here the side arm is having the axis parallel to the H field, that is why it is called as H arm, and you can notice the direction of the wave propagation here. and this can be represented in this way. This is 1, 2 the collinear arms, and this is the port 3 which is the H arm. Now, let us first understand about E-plane T. Let us analyze the E-plane T. As we already discussed about the symmetry property, from the considerations of the symmetry as well as the phase relationship of the waves in each arms, we can justify that a wave which is incident at port 3 will result in waves at ports 1 and 2. Whenever there is a wave incident at port 3, we will be having the waves at ports 1 and 2 which are equal in magnitude, but opposite in phase. A wave incident at port 3 results in waves at ports 1 and 2, but they are equal in magnitude, but they will be opposite in phase. So, we can write the S parameters as S31 is equal to S13 is equal to minus S23, that is equal to minus S32. Similarly, from symmetry S12 is equal to S21, and similarly, if I go for two in-phase input waves which are fed to ports 1 and 2 of the collinear arm, it means we are feeding the input at both ports 1 and 2 of the collinear arm. The output at port 3 will be opposite in phase and it will be subtractive. What is the output that we expect from port 3 will be a opposite phase output as well as it is a subtractive output. And from the analogy with the voltage relationship in the series circuit, we can justify that E-plane junction can also be called as a series junction. Now, coming to the next property, all diagonal elements of the S matrix of E-plane T junction cannot be 0 simultaneously, since the T junction cannot be matched to all the 3 arms simultaneously. This is very important, because when I tell the 3 arms, we cannot do the perfect matching for all the 3 ports simultaneously. Whenever we want to check the output, one of the port can be matched terminated. One is treated as input and the other is treated as output, means the third one will be matched terminated. So, all cannot be matched terminated simultaneously. So, we tell that all the diagonal elements of S matrix of E-plane junction cannot be 0 simultaneously. Next, moving on to the next property, if I consider the port 3 has matched, the S matrix of E-plane T can be derived now. Let us assume that we are considering the port 3 as a matched terminated, it is matched terminated. Now, let us find the S matrix for this E-plane T. Let us denote the incident and outgoing signal variables as ith port by AI and BI respectively. It means I represent the incident signal variable by AI and outgoing signal variable by BI. Input is AI and output is BI at the ith port. Now, for an input power at port 3, the net input power to port 3 will be, for an input power at port 3, the net input power to port 3 will be 1 by 2 into mod of A3 square minus mod of B3 square, that can be represented as of into, we will take mod of A3 square outside, because whenever I want to express the S parameters, that is having the ratio B by A. So, in order to bring it in that form, we will take mod of A3 square outside this bracket, and that will be now 1 minus mod of B3 square by mod of A3 square. What is mod of B3 square by mod of A3 square? It is mod of S33 square. So, and the output power now can be represented as 1 by 2 into mod of B1 square plus mod of B2 square, that is equivalent to now mod of A3 square into mod of S13 square. And since we know that mod of S31 is equal to mod of S32 by symmetry, we can just replace that by this form. Now, for a lossless junction, the input power must be equal to the output power, because whenever we tell there is no loss in the junction, we can justify that the input power is equal to the output power. So, we can just equalize these two now. So, 1 by 2 mod of A3 square into 1 minus mod of S33 square is equal to mod of A3 square into mod of S13 square. Or we can also represent this as, here in this equation mod of A3 square will get cancelled. So, remaining will be 1 minus mod of S33 square is equal to 2 into mod of S13 square. Now, if we use suitable matching elements, there is a suitable matching elements means whenever there is an input at port 3, the output can be again 0. It means there is no reflection. Whenever there is no reflection, we tell that S33 is equal to 0. So that we can write mod of S13 as equal to 1 by root 2. From this, if I substitute S33 as 0, I will get mod of S13 as equal to 1 by root 2. Now, from the symmetry characteristics, as we know S13 is equal to S31. Okay, since S13 is equal to 1 by root 2 already, we can substitute S31 as also equal to 1 by root 2. Now, this S31 is again equivalent to what? Is again equivalent to, since it is out of phase, the output is out of phase, we can substitute that the value is equal to minus 1 by root 2 for S23, that is equal to S32 is equal to minus 1 by root 2. Now, based on the power consideration, we can show that S11 is equal to S22 is equal to 1 by 2. As well, we can prove that S12 is equal to S21 is equal to 1 by 2. This we have already discussed. So, this is for which condition? This is for S33 is equal to 0. Therefore, when I tell there is a perfect matching at port 3, using this all this realization analysis whatever we have done with respect to the properties, now we can find out what is the S matrix of this E plane T. Therefore, the S matrix is equal to S11 is what? 1 by root 2. S12 is what? It is again 1 by 2. S13 is how much? It is 1 by root 2. Next, S13 is equal to S21 is equal to S12. So, this is again equivalent to this value. And next S22 we have already know that it is 1 by 2. Next, this is S22, next S23. What is the value of S23? It is minus 1 by root 2. S23 is minus, it is minus 1 by root 2. Next, coming to S31. S31 is nothing but S13. Similarly, S32 is nothing but S23. So, minus 1 by root 2. And what is S33? It is perfectly matched by using suitable matching elements. We got to know that S33 is 0. Now, from this we can just take 1 by 2 outside and finally write the matrix in this way: 1 1 root 2 1 1 minus root 2 root 2 minus root 2 0. This is the final S matrix of the E plane T whenever there is a perfectly matching condition at third port, that is port 3. Now, let us continue this further. With the cases corresponding to this S matrix. Now, in this, as you can see, the case 1 is whenever there is an input at port 3 and no outputs at port 1 and 2. It means A3 is not equal to 0 and A1 and A2 is equal to 0. It means there is an input at port 3. The inputs are not V1 at either port 1 or port 2. It means A1, A2 is equal to 0. Since there is an input at port 3, A3 is not equal to 0. Now, what are the outputs here? B1 is equal to 1 by root 2 A3, B2 is equal to minus 1 by root 2 A3 and B3 is equal to 0 because there is no reflection at port 3, it is perfectly matched. Now, moving on to the case 2. There is an input at port 1 and 2. It means A1, A2 is equal to A. There is an input at ports 1 and 2. And there is no input at port 3. There is no input at port 3 means A3 is equal to 0. So, what is the output at port 1 and 2 as well as 3? At port 3 the output is 0 when both the ports are been given the input. What is the output at port 1 now? B1 is equal to A by 2 plus A by 2, that is equal to A. Similarly, B2 is equal to A by 2 plus A by 2, that is equal to A. What about B3? The B3 value is equal to 0. Similarly, moving on to case 3. In case 3, there is input at port 1 and port 2 and no input at port 3. Input at port 1 and port 2 and no input at port 3. Sorry, the case is wrong, and the case mentioned is wrong here. There is input at port 1 and no inputs at port 2 and port 3. Only input at port 1. It means A1 is not equal to 0. There are no outputs at which port? P2 as well as P3. So, it means what? A3, A2 is equal to 0. In such a case, what is the value of P1? It is A1 by 2. What is the value of B2? It is A1 by 2. What is the value of B3? It is minus A1 by root 2. Only one port is being given the input. We are checking the outputs at the remaining ports. When input is given at port 1, suppose if we assume the input at port 1, the output at port 1 and port 2 will be A1 by root 2, but the output at port 3 will be minus A1 by root 2 because it is out of phase signal. It is a out of phase signal. Like this, we can take the cases with respect to this E-plane T and we can do the analysis with respect to in which port we are giving the input. In the case 1, we got to know that we are giving the input at port 3 and we are not giving any input at ports 1 and 2. In such a case, the output at port 1 is 1 by root 2 A3, B2 is minus 1 by root 2 A3 and B3 is 0. Similarly, in the case 2, we are giving input at port both the ports 1 and 2, no input at port 3. It means A1, A2 is A and A3 is 0. In such a case, B1 is A as well as B2 is A, but B3 is equal to what? 0. Now, moving on to the case 3, there is an input given at either port 1 or port 2 and there is no input given to the another collinear port and no input given to the E arm. In such a case, the output at port 1 will be A1 by 2, output at port 2 will be A1 by 2 and output at port 3 will be minus A1 by root 2. Okay. This is about the analysis of the E-plane T. We have got to know the different types of waveguide T's. We started our analysis with the E-plane waveguide T. What is V-plane waveguide T? What is the pictorial representation of the E-plane waveguide T and what are the properties that can be applied for this E-plane waveguide T, and finally what is the S matrix that can be realized, and some of the cases with respect to the S matrix can be analyzed in this session. In the next session, we will be discussing about the H-plane T. Thank you. Thank you.